Now, it would be wonderful if we had some type of formula to help us find the vertex instead of completing the square each time and writing it in this form. And it is true that we do have a formula. Let's look at that formula. This is what we call the vertex formula. The graph of f of x equals ax squared plus bx plus c, where a is not equal to 0, is a parabola with vertex. Notice the x value of the vertex is negative b over 2a, and then of course the y value is f of negative b over 2a. So let's now use that vertex formula to find the vertex. Here, notice I have a quadratic function, so we know the graph is a parabola. Let's first find the vertex of the parabola. Now notice A is 4, B is 4, and C is negative 3. Let's use that vertex formula. Let's find negative B over 2A. So that's negative b is 4 over 2 times, and then a is 4. That's negative 4 over 8, so that's negative 1/2. Negative 1/2. What is that so far? That is the x value of the vertex. Now, how do we find the y value of the vertex? In the formula, it says find f of negative b over 2a. So obviously, find f of negative 1/2. The reason being that this is a point on the graph, so obviously we want it to be an ordered pair solution of this function. So we would find f of negative 1/2, and that's 4 times negative 1/2 squared plus 4 times negative 1/2 minus 3. Now I'll let you go ahead and simplify that right side. If you do simplify it, you will have a value of negative 4. There is our vertex. I would suggest first graphing the vertex before you look for any intercepts, because your graph, your parabola, may not have x-intercepts. So negative 1/2, negative 4, there is the vertex of my parabola. If this parabola opens downward, there are no x-intercepts. Does this parabola open upward or downward? You look at the value of a as usual. A is positive 4. It's a positive number. The parabola opens upward, so I will have 1 y-intercept and 2 x-intercepts. Now, how do we find these intercepts? We find them just as we do for any other graph. We find y-intercept by letting x be 0. So let x be 0, and that's 4 times 0 squared plus 4 times 0 minus 3. F of 0 is negative 3. So we have the ordered pair 0, negative 3. That is our y-intercept. There's the y-intercept. Continuing upward, we know we're going to have 2 x-intercepts. Let's see how we find them. How do you always find an x-intercept? You let y or f of x be 0. So let's go back and let's let y or f of x be 0. And this is now the equation I need to solve. What type of equation is it? It is a quadratic equation. We hope this factors. If it doesn't, we use a quadratic formula. So let's see if this right side factors. What about 4x and x? 3 and 1. And I'm looking for a middle term of 4x. I don't think that's going to work. Let's try 2x and 2x and see if we get anywhere. Okay, factors of 4x squared. Let's try 2x and 2x. And what if we try 3 and 1? Let's see what that gets us. First times first is 4x squared. That's 6x minus 2x, which is 4x. And last times last is minus 3. So I have factored. You do next, you what? Set each factor equal to 0. So 2x minus 1 is equal to 0. Solve that, you'll have 1/2, or 2x plus 3 equals 0. If you solve that for x, you'll have x is negative 3 over 2. Those are my two x-intercepts. So they are what now? 1/2, 0, and negative 3/2, 0. There we go. Let's plot those points. 1/2, 0, negative 3/2, negative 1/2, 0. And now that's enough to sketch the graph of our function. And we have the vertex, we have the intercepts. Let's just go ahead and sketch that. There it is. It should look symmetric, so do the best you can as you sketch. And there's the graph of f of x equal 4x squared plus 4x minus 3. Let's try one more graph. Let's graph another function. This time, let's try something with a negative. Let's graph, say, f of x equals negative x squared plus 2x minus 1. Now, because of that negative, what do you already know about the graph of the function? It is a parabola opening downward. Let's find the vertex of the parabola. The vertex has x-coordinate negative b over 2a. So in our case, negative b is 2 over 2 times a is negative 1. That's negative 2 over negative 2, which is a positive 1. So the x value of the vertex is 1. How do you find the y value? You find f of 1. I'll let you find f of 1, but if you go through everywhere there's an x, you replace x with 1, you'll find that f of 1 just happens to be 0. So that is our vertex. Let's plot that vertex. 1, 0. The parabola opens upward or downward? It opens downward because a is negative. So do I have any more x-intercepts? It just so happens that the vertex lies on the x-axis, so we will have no more x-intercepts. It does have one x-intercept. It's the same as the vertex. But this graph will have a y-intercept. How do we find the y-intercept? We let x be 0. So let's let x be 0. And we're finding f of 0. So that's negative 0 squared plus 2 times 0. Oops, that's minus 1. And what do we have? That's 0 plus 0 minus 1. F of 0 is negative 1. So we have the ordered pair 0, negative 1. Now be careful. Don't forget that this is the vertex, and then 0, negative 1, that is the y-intercept. Believe it or not, that's enough to graph our parabola. Now, if you're uncomfortable, just draw a table and come up with more ordered pair solutions of this function. But this is enough. Just keep in mind the symmetry. And there we have it. There we go. Keeping in mind the symmetry, I will make it just as wide. On the other side, there is the sketch of this function f of x, or y, if you'll have it, equals negative x squared plus 2x minus